Hello everyone and welcome to the Sleep and Learn channel. Tonight, you'll drift into one of the calmest journeys through the universe, from the slow expansion of space to the silent movement of glaciers and stars that live for trillions of years. These are stories where time flows so slowly, it almost stands still. Get comfortable, relax, and let yourself sink into the quiet rhythm of the slowest things in the universe. Subscribe to the channel so you don't miss new relaxing videos for sleep, learning, and peaceful discovery. The slow expansion of the universe. When we imagine the universe, we often think of explosive events, supernovae, blazing stars, and galaxies racing through space. Yet one of the most important processes in the cosmos is happening so slowly that no human has ever directly witnessed its change within a lifetime. The universe itself is quietly expanding. This discovery began in the early 20th century when the astronomer Edwin Hubble observed that distant galaxies appear to be moving away from us. The farther a galaxy is, the faster it seems to recede. This observation became one of the foundations of modern cosmology and revealed that space itself is stretching. Galaxies are not flying apart through space like shrapnel from an explosion. Instead, the fabric of space between them is gradually expanding. Despite the enormous distances involved, this expansion is incredibly gentle on small scales. Entire galaxies remain intact because gravity holds their stars together. Even galaxy clusters remain bound for billions of years. The expansion becomes noticeable only across vast cosmic distances, millions or billions of light years. To understand just how slow and subtle this process is, imagine two galaxies separated by 1 million light years. Because of cosmic expansion, the distance between them increases by only a tiny fraction each year, far less than the width of a human hair compared to the total distance. Yet over billions of years, these tiny changes accumulate, gradually reshaping the architecture of the cosmos. What makes this phenomenon even more fascinating is that the expansion is not slowing down. Observations made with space telescopes studying distant supernovae revealed that the universe is actually expanding faster over time. Scientists believe this acceleration is caused by a mysterious force known as dark energy, which appears to permeate all of space. Even though dark energy dominates the universe today, its influence unfolds extremely slowly. The acceleration it causes is so subtle that only precise astronomical measurements across vast distances can detect it. On human timescales, the universe appears calm and unchanging. From a relaxing perspective, this slow cosmic expansion reminds us that the largest structures in existence evolve at a peaceful pace. Galaxies drift apart over billions of years, clusters slowly rearrange themselves, and the universe gently stretches like a vast cosmic ocean slowly rising. In fact, if a human could live for 1 trillion years, the night sky would look very different. Many distant galaxies would gradually fade from view as they move beyond the observable horizon of the universe. But this transformation would happen so gradually that even such an unimaginably long-lived observer might barely notice the change from one millennium to the next. The expansion of the universe is therefore one of the slowest grand processes known to science. It reminds us that while some cosmic events are violent and dramatic, many of the universe's most important transformations occur in near silence, unfolding patiently across unimaginable spans of time. And this is only the beginning. Beyond the quiet stretching of space itself, the universe contains many other phenomena that evolve with extraordinary slowness, from drifting galaxies to ancient stars that burn for trillions of years. The slow birth of mountains. Among the slowest and most patient processes in the universe is the formation of mountains. To us, mountains appear permanent and immovable. Their towering peaks, rocky cliffs, and snowy summits seem as if they have existed forever. Yet mountains are not eternal structures. They are slowly born, shaped, and transformed over immense periods of time through the quiet movement of the planet itself. The surface of Earth is not a single solid shell. Instead, it is divided into enormous moving sections called tectonic plates. These plates float on the slowly shifting layers of hot rock beneath the crust. Their movement is extremely slow, often only a few centimeters per year, roughly the speed at which human fingernails grow. Yet this tiny motion, sustained over millions of years, can create some of the most dramatic landscapes on Earth. When two tectonic plates move toward one another, the edges of the plates begin to press together. The immense pressure causes the crust to fold, wrinkle, and slowly rise upward. Over long stretches of geological time, these folds grow higher and higher, eventually forming massive mountain ranges. One of the most famous examples of this slow process is the rise of the Himalayas. These mountains began forming around 50 million years ago when the Indian tectonic plate slowly collided with the Eurasian plate. Even today, the mountains continue to grow slightly taller every year, although erosion from wind, rain, and ice constantly works to wear them down. This balance between growth and erosion creates a quiet rhythm in nature. While tectonic forces push mountains upward, rivers carve valleys, glaciers grind away rock, and storms carry tiny particles of stone down to the sea. The mountains are always changing, but the transformation is so gradual that it unfolds far beyond the scale of human observation. Interestingly, some mountains we see today are only the remnants of much larger ancient ranges. Hundreds of millions of years ago, entire mountain systems rose and then slowly disappeared as erosion gently lowered their peaks. What remains are softened hills and worn ridges that still carry the memory of their former height. From space, the formation of mountains would look almost like a slow-motion wave passing across the surface of the planet. The crust bends, rises, and reshapes itself over millions of years, sculpting continents in silence. This patient creation of mountains reminds us that some of the most powerful forces in nature operate not with sudden violence, but with extraordinary patience. A mountain may take tens of millions of years to rise, yet it can stand for hundreds of millions more, quietly watching the world change around it. In this way, mountains are monuments to slow time. They grow, erode, and renew themselves across spans of time that stretch far beyond human history. And in the vast story of the universe, they represent one of the most peaceful and gradual transformations our planet can offer. The silent journey of glacier. Among the slowest and most peaceful movements on Earth is the quiet journey of glacier. At first glance, glaciers appear completely still, massive rivers of ice frozen in place among mountains and polar landscapes. Yet in reality, glaciers are slowly moving, flowing across the land with a patience that unfolds over centuries. A glacier forms when snow accumulates year after year in cold regions where winter snowfall exceeds summer melting. Over time, the weight of new snow compresses the layers beneath it. The snow gradually transforms into dense ice, forming enormous sheets that can grow hundreds or even thousands of meters thick. Under such immense pressure, ice behaves in a surprising way. Although it appears solid, glacier ice slowly deforms and flows, much like an extremely thick liquid. This movement is almost unimaginably slow. Many glaciers advance only a few centimeters or meters each day. To human observers standing nearby, the glacier seems completely motionless. However, over long periods of time, this quiet motion becomes powerful enough to reshape entire landscapes. As a glacier moves, it carries rocks, sand, and debris locked within its ice. These materials grind against the ground below, slowly carving valleys, smoothing mountain slopes, and creating the distinctive U-shaped valleys found in many alpine regions. Some of the most spectacular landscapes on Earth were formed through this slow glacial movement. The deep fjords of northern regions, the polished granite walls of famous valleys, and the countless lakes left behind after glacier retreat all tell the story of ice slowly sculpting the planet. One remarkable example can be seen in Perito Moreno Glacier, where enormous walls of blue ice stretch across the landscape. Although parts of the glacier occasionally crack and break into the water below, the overall mass continues its gradual forward movement, advancing only a small distance each year. Glaciers also act as frozen archives of Earth's past. Tiny air bubbles trapped in the ice preserve ancient samples of the atmosphere from thousands of years ago. By studying these frozen layers, scientists can learn about past climates, volcanic eruptions, and even subtle changes in the planet's environment. Despite their slow pace, glaciers are incredibly influential. Over thousands and millions of years, their steady movement has shaped mountain ranges, carved valleys, and distributed sediments across continents. What appears to be frozen stillness is actually one of the most powerful sculpting forces in nature. Watching a glacier reminds us that time in nature often flows at a different rhythm than human life. The ice advances quietly, year after year, almost unnoticed. Yet given enough time, even this gentle motion can transform the face of the Earth. The gentle lives of the slowest animals. In a universe filled with speed, from rushing rivers to orbiting planets, it may seem surprising that some living creatures move through life at an extraordinarily slow pace. Yet for many animals, slowness is not a weakness but a carefully evolved survival strategy. Some of the calmest and most patient creatures on Earth live in rhythms that appear almost motionless compared to the busy activity around them. Perhaps the most famous slow animal is the sloth. Sloths spend most of their lives hanging quietly from tree branches in the tropical forests of Central and South America. Their movements are incredibly slow and deliberate. A sloth may take several minutes just to shift its position along a branch. Even when traveling through the forest canopy, it rarely moves faster than a few meters per minute. This slow lifestyle is closely connected to the sloth's diet. Sloths mainly eat leaves, which contain very little energy and are difficult to digest. To survive on such a limited food source, their bodies have evolved extremely slow metabolisms. In fact, a sloth may take more than a week to fully digest a single meal. By moving slowly and conserving energy, it perfectly matches the quiet rhythm of its environment. Another remarkable slow-moving creature is the giant tortoise. These ancient reptiles move across the land at a peaceful pace that has remained almost unchanged for millions of years. Their steady steps may seem unhurried, yet this slow lifestyle allows them to conserve energy and survive in environments where food may not always be plentiful. Giant tortoises are also famous for their extraordinary longevity. Some individuals have lived for more than a century, quietly wandering across volcanic islands, grazing on plants, and resting beneath the sun. Their calm and patient lives demonstrate how slow movement can be closely connected with long life. The ocean also holds animals that move with remarkable slowness. The sea cucumber, for example, drifts slowly across the ocean floor, sometimes moving only a few centimeters per hour. Its life consists of gently filtering organic particles from the sand and water. In the deep sea, where energy is scarce and food arrives slowly from the surface, this quiet pace is perfectly suited to survival. Even among mammals, reptiles, and marine creatures, slow movement often serves as a form of protection. By remaining still or moving very gradually, animals become less noticeable to predators. A sloth covered in moss-like algae blends perfectly with tree branches, while many slow sea creatures appear almost like rocks or coral on the ocean floor. These animals remind us that nature does not always reward speed. In many environments, patience and energy conservation are far more valuable strategies. By living slowly, these creatures maintain a delicate balance with their surroundings. In a way, Observing the slowest animals on Earth can feel almost meditative. Their gentle movements and calm routines reflect a different rhythm of life, one that unfolds quietly, without hurry. And beyond animals, the universe itself contains processes that unfold even more slowly. The slow life of the longest living stars. Among the slowest and most peaceful processes in the universe is the quiet life of certain stars. While some massive stars burn brightly and explode after only a few million years, other stars live far longer, so long that their lifetimes extend far beyond the current age of the universe itself. The most patient of these cosmic objects are known as red dwarf stars. These small and relatively cool stars are the most common type of star in our galaxy. Although they shine much more dimly than larger stars like our Sun, they possess an extraordinary ability. They burn their fuel incredibly slowly. Stars shine because nuclear fusion occurs deep inside their cores. Hydrogen atoms fuse together to form helium, releasing enormous amounts of energy. In massive stars, this process happens quickly and intensely, causing them to exhaust their fuel in a relatively short time. Red dwarfs, however, fuse hydrogen at a very slow and steady rate. Because of their small size and efficient fuel usage, red dwarf stars can continue shining for trillions of years. To put this into perspective, the universe itself is about 13.8 billion years old. Many red dwarf stars that formed in the early universe have barely begun their long lives. In cosmic terms, they are still in their earliest stages. One fascinating aspect of red dwarf stars is how stable they can be. Unlike larger stars that experience dramatic changes over time, many red dwarfs evolve extremely slowly. Their brightness may remain relatively constant for unimaginable stretches of time, creating some of the most stable stellar environments known. Astronomers believe that long after larger stars like our Sun have faded away, red dwarfs will continue to illuminate the universe. In fact, these quiet stars may dominate the future cosmos for trillions of years. During that distant era, the universe could appear calmer and darker, with only these small, patient stars still glowing in the vastness of space. Our own galaxy, the Milky Way, contains hundreds of billions of stars, and the majority of them are red dwarfs. Many are so faint that they cannot be seen with the naked eye from Earth, yet together they make up the silent backbone of the galaxy. Some nearby stars, such as Proxima Centauri, belong to this class. Although tiny compared to the Sun, these stars may still be shining when countless generations of galaxies and planets have already changed beyond recognition. In a way, red dwarf stars represent the ultimate example of cosmic patience. They do not blaze with dramatic brilliance or end their lives in spectacular explosions. Instead, they glow steadily and quietly for timescales so long that they are almost impossible for the human mind to imagine. Their gentle light reminds us that in the universe, longevity often belongs to those who burn slowly and steadily. The slow drift of continents. One of the most extraordinary slow processes on Earth is the quiet movement of entire continents. Although the ground beneath our feet feels stable and unchanging, the continents are constantly drifting across the surface of the planet. This motion is so slow that it is impossible to notice within a human lifetime, yet over millions of years it reshapes the entire map of the world. This process, known as plate tectonics, describes how massive sections of Earth's crust move over the semifluid layer beneath them. These tectonic plates carry continents, oceans, and mountain ranges, slowly shifting their positions over time. On average, continents move only a few centimeters per year, about as fast as fingernails grow. Hundreds of millions of years ago, all continents were joined together in a single supercontinent known as Pangaea. Over time, its pieces drifting away from one another to form the continents we recognize today. The Atlantic Ocean, for example, continues to widen very slowly as the Americas drift away from Europe and Africa. If we could watch this movement from space across millions of years, it would resemble a slow and graceful dance. Continents would gently separate, collide, and reshape themselves. New oceans would open while others would close, and mountain ranges would rise where landmasses meet. Even today, this movement continues. Africa is slowly drifting toward Europe, Australia is moving northward, and the Pacific Ocean is gradually shrinking as its tectonic plate is pulled beneath surrounding continents. These changes are incredibly slow, yet they are constantly shaping the future of Earth. The slow drift of continents reminds us that the planet itself is alive with motion, even when everything appears still. It is a quiet transformation that unfolds over deep time, patiently rewriting the geography of the world. The slow evaporation of black holes. Among the most mysterious and slowest processes in the universe is the gradual fading of black holes. These objects are often imagined as eternal and unchanging, swallowing everything that comes too close. Yet, according to modern physics, even black holes are not truly permanent. The idea that black holes can slowly lose energy was first proposed by the physicist Stephen Hawking. He suggested that black holes emit a faint form of radiation, now known as Hawking radiation. This radiation causes black holes to lose an incredibly small amount of mass over time. For large black holes, this process is unimaginably slow. A black hole with the mass of our Sun would take far longer than the current age of the universe to evaporate. Supermassive black holes, like those found at the centers of galaxies, would require trillions upon trillions of years to disappear completely. From a human perspective, this process is almost perfectly still. A black hole would appear unchanged for countless generations, silently existing in the darkness of space. Only over incomprehensible spans of time would it begin to shrink and eventually fade away. In the distant future of the universe, long after stars have burned out and galaxies have grown dark, black holes may be among the last remaining objects. Even then, they will slowly release their energy into space, gradually dissolving into faint radiation. This idea presents a quiet and almost poetic vision of the universe's far future. Instead of ending in a sudden event, the cosmos may slowly fade, with even its most powerful objects gently disappearing over time. The evaporation of black holes is perhaps the ultimate example of cosmic patience, a process so slow that it exists far beyond any human sense of time. It reminds us that in the universe, even the most extreme and powerful phenomena eventually yield to the quiet passage of time.